Our project is ECG Analyzer. ECG is an important biomedical parameter and is used clinically in diagnosing of various diseases and conditions associated with the heart. Acquisition of a real-time ECG signal requires an expensive machines and experienced doctors who can interpret the output signals. However, in developing and underdeveloped nations, due to the scarcity of resources and manpower, especially in the rural areas, common people cannot make use of this technology. Therefore, this project mainly focuses on the development of accurate, low-cost, user-friendly and real-time ECG acquisition using a virtual instrumentation to know about the general cardiac abnormalities and facilitate the improved medical treatment. It also presents the development of the web browser based on the remote monitoring of an ECG system, whereby the remote patient ECG input are analyzed and monitored in real time remotely. ECG so recorded can be studied by practitioners sitting at a distance through the internet, thereby enabling long distance diagnosis. Based on this database, it is possible to analyze a bradycardia and tachycardia and detect the diseases such as the atrial flutter, atrial fibrillation, supraventricular tachycardia. This analysis is implemented in the LabVIEW. The main aim of this project is to develop an algorithm for automatically computing an ECG interval measurements and diagnosis the cardiac deformabilities as a measure of precaution. The project prevents the functionally working hardware model for acquisition of ECG signal with the almost negligible noise interference with National Instrumentation LabVIEW. The complete block diagram of the project is shown on the screen. According to this block diagram, we have to take the ECG of the patient, then amplify the signals using ECG amplifier and filter the signal. Then the filtered signal will be passed to the data acquisition system. In that, we are converting analog signal into the digital signal, so we can transfer the signal to the PC and can be processed. Then a signal is collected in LabVIEW and the signal is processed in LabVIEW through the different detection and different programs and algorithms. We can detect the disease in the LabVIEW. Now, for understanding this, first we have to understand the PQRST waveform. In this, this is the general PQRST waveform of the normal patient. In this portion is called the P wave. This is the QRS complex. This is the T wave, and this is the U wave. In normal patient, generally the U wave is negligible. And in this, for the normal patient, the time duration of the PQRST waveform of each and everything, the P wave, PR interval, QRS complex, QT interval, RR interval are fixed, and their voltage is also fixed. So if we able to measure these intervals of the abnormal patients, and we can compare these values with the values of the normal patient, we can detect the many diseases. This is the time durations of the P wave, PR segment, PR interval, QRS complex, ST segments, T wave, ST interval, RR interval, QT interval of a normal patient. So by comparing the values of the abnormal patients with the normal patient, we can detect the diseases. Now, for this, we have to first design the data acquisition system. For that, we have made the three circuits, and first one is made for the one is the power supply, which gives the power to the circuits. Now, first we have to supply the ECG signal to the ECG amplifier. This is the instrumentation amplifier whose gain is 1110, and by checking the signals in a CRO, we get the signal like this. So if we are giving the ECG signal is in a millivolt, but due to its gain, we are getting this high voltage. Then for a clear view of the ECG signal, we have to make the filters. So we have designed a 6 Butterworth filter and a notch signal. Through this, we are transferring a signal to the 18F4550 microcontroller microcontroller in which the signal, analog signal, is converted into the digital signals, and then through for the serial communication we are transferring the signals to the MAX232, and then we have taken the 18F4550 for the USB purpose, but it is not working in our project, so we have used it in serial as a serial communication, and then we have used a serial to USB converter and transfer the signal in a computer using this circuit. So this is our DAC system, and this for using this filter, using the Butterworth filter of the 6 order Butterworth filter, we are getting the signal like this. This is the ECG signal of the normal patient, and so we have to process the signal in a ECG. We have to process the ECG signal in a LabVIEW for further getting a clear view of it. Now after filtering the signals in a LabVIEW using the 30 order Butterworth filter, we are getting the patient signals this much clarity. Right now we are not getting the disease patient, so we are taking the ECG of a normal patient, a normal person. And we have designed another VI which through that we can detect the QRS magnitude, means 60 Hz artifact amplitude, then T wave magnitude, fluctuation in amplitude, heart rate, and this is the substimulated ECG VI which we are getting in our panel only. So through these all parameters, by comparing it with the normal patient's parameter, we are getting the we can diagnose the diseases. Now the another main feature, and after diagnosing the patient, we can get the we can have a view of our VI like this, and proper VI. This is the block diagram view, and through this we can show the proper. This is the P wave, P duration, Q wave, R wave, S wave, T wave duration, PR interval, QT interval, ST interval of the different patients, and which we have recorded first, and we have shown in this, and we are comparing these values with the normal patients, and we can show through this comparing we can show the different diagnosis of the patient. Now now the main another feature of our project, that using this we can send this VI format to the doctor directly using the internet facility. For that, first we have to go to the whatever VI we have to want to send to the doctor, we have to go to the VI's front panel. In that we have to go to the tool, and then we have to select for the web publishing tool. In that we will get this type of dialog box, and then in that we have to select the VI, whatever VI we want to send to the doctor. We have to select that VI. Then we have to means whatever the embedded, snapshots, monitor, whatever you have to set, you can select. First we will select the embedded, then request control, we have to select this option. we can see the this type of print preview in the browser. Means we can send this type of photo and to the doctor. Then we have to select the next. Then this will show the document title, whatever title you want to give to that. Then you can title it, means you can give the header to it and a footer. Then you can request the doctor that this is the patient's ECG, and so please prepare the operation theater or instruments till the patient reach to the hospital. You can request it to the doctor and send it to the through footer. Then you have to local directory. Then next you have to select next, and you have to write the file name, URL, as we are sending this pictures through the URL, and this is the local directory, and then save to the disk. Okay, then due to this we will get the snapshot. We can send the picture like this to the doctor. This is the snapshot of it. This type of view can be seen by a doctor, and a live ECG can be seen by a doctor. In that there is a many facility in it that after every 2 seconds or any, we can send this picture automatically to the doctor if we are setting. So this is our project, and please consider it. Thank you.